Second lesson in this unit is on compound interest. Compound interest is the way that banks and pretty much any financial institution calculates interest. All right, how is it different? Compound interest is the interest earned on or paid on both the principal and the accumulated interest. Okay, now there's an exercise here that you can do, but I'm going to give you the shortened version of it. All right, if you remember yesterday, I showed you that simple interest, went up like this, the same amount every time. Whatever the interest rate was for, or the interest accumulated, and yesterday it was $600, it went up by $600 every time. It was a linear function. Okay, this is simple interest. Okay, compound interest works a little bit different. Okay, and a compound interest could be calculated, it doesn't have to be yearly, but let's assume that it's yearly. So you'd start off with the same amount, okay, and after 1 year you would still have the same amount. But to calculate the next amount, it would take the interest on not only the original amount, it would take the interest on the accumulated amount. So instead of, in our example from yesterday, what was the original amount? 15,000. Instead of calculating the interest on 15,000 and adding another 600, it would take the interest on 15,600. Okay, the original plus the amount that you have earned, and so this graph would end up looking a little bit more like this. We'll talk about this more later. This is called an exponential graph because it increases by more and more every year. So compound interest is a good thing if you're earning money. Okay, so we're going to spend some time going over that today. Here are some interest from simple interest, some comments. Make sure you are reading through this. The compound interest is determined by applying the interest rate to the sum and the principal and the accumulated interest. This is where we're going to spend our time. So here's a graph showing the difference between compound and simple. Okay, you can try a couple questions, but let's get into actually doing some of this compound interest. Okay, so we've established what compound interest is. We know what future value is. Compounding period, okay, this is what the interest is usually determined over. For simple interest, we used 1 year, or one for it happened every year, but compound period could be every, semi-annually. In other words, twice a month. Could be quarterly, which would be every 3 months, 4 times a year. Could be every month. Could be weekly. Could be daily, etc. All right, and there's a different formula that you're going to use. I would put that in my cheat sheet. By the way, you might want to put some of this stuff in your cheat sheet as well. Whatever you think you don't really understand and you might need a little bit of a prompt on a test. Okay, so it says Yvonne earns $4,300 in overtime on a carpentry job. She invested the money in a Canada savings bond, earning 3.8%. Now it's not simple interest, it's compound interest, and it's compounded annually. Okay, so let's just kind of go through this. The future value, this is what we don't know in this case. We start with 4,300. The interest rate is 3.8. So 0.038. The compounding period, how many times is it compounded in a year? Just once. And how many years? 10 years. So A equals 4,300 times 1 plus 0.038 over 1, and then 1 times 10. Now, my advice to you is to learn how to do this with your calculator. Okay, in other words, put it all in at one time, rather than little bit by little bit. Okay, and so the final amount, if you put this all in the calculator, is $6,243, and okay, that's what it says. So whenever you have dollars and cents, and this will cost you a mark if you don't do that, you're going to round off to 2 decimal places. So this 9 is going to round that off to a 0, so you're actually going to have 70 here. Okay, let's see if you got that answer when you put it in the calculator, because if you didn't, you need to ask about this in class as soon as you get to class. so we can go through what did you not put in correctly. Okay, chances are this might be a place you should maybe have brackets there. You need to learn how to do that. Okay, give that a try. We need to get good at our calculators. Okay, another one. What is a future value after 5 years? So let's go after 5 years. So the future value is going to be, put 23,000. What is the interest rate? Wow, that's a nice interest rate. And it says compounded semi-annually. So this is every 6 months or twice a year. And so then we would have 2 times 5. All right, this turns out to be $44,405.87. Couple of tips for you. I would just put it in as 10. I wouldn't even worry about putting 2 times 5. I think if you can do something mentally, you should do that. Okay, let's try after 10 years. So A would be the principal, 23,000. This is the same, but now it's going to be 2 times 10. And it is worth $85,733.96. Okay, so when you're doing these notes, don't just copy down what I'm writing. I'd like you to try them first. Try the answer first. Use your calculator, write it down, pause the video if you need to. You need to engage in this learning to try to actually know what you're doing, because you're not going to get prompts during your test. Okay, let's compare. What do you notice? Well, it went up by a lot. Okay, an awful lot. So we should probably say that. So let's say after 5 years, the investment increased. Okay, how much did it increase? 44,405.87. Take away 23,000. It increased, so what is that? It's $21,405.87. Okay, what did it increase after 10 years? After 10 years, the investment increased. So let's put 85,733.96, take away 23,000. This is going to be $62,733.96. What do you notice there? Okay, well, in the first 5 years, it increased $21,000. In the next 5 years, it's increased much more than another $21,000. This is the beauty of compound interest. All right, as you accumulate money, you get more and more interest. Okay, so you can see here in 10 years it went up $62,000, in 5 years $21,000. It's going up much faster as you get the investment in longer and longer. If the investment had earned simple interest, would the relationship between principal and future values have been the same? No. With simple interest, you'd get the same amount of interest every year. It would have been linear. You wouldn't have this growth. Okay? You know, if it was simple interest, you would have something like you would have made 20,000 after 5 years, and then you would have made 40,000 after 10 years. The amount would be the same. Okay? So, let's try another one. Jolly and her daughter Lena plan to invest $1,500 in an account with interest rate of 9% compounded monthly. Okay, compounded monthly means 12 times a year. If both women hold their investments until age 65, what will the difference in their future values be? Okay, so let's quickly do this. 65 take away 50. So this person's going to be investing for 15 years. So let's write that. The principal, 1,500, 1 plus 0.09, compounded monthly, so we got to put 12 here, and then 12 times 15. So let's figure out what this person would make. 1,500 times 1 plus 0.09 divided by 12 to the power of 12 times 15. So this is worth $5,757.06. Now this is nice. You don't have to. That's not the interest. That's what the value of the investment is. That includes the 1,500 that was originally there. That's different than the simple interest. Simple interest formula only gives you the interest. Okay, let's figure out Lena's. So this is going to be 47. So A is going to be 1,500 times 1 plus 0.09, 12 times 47. Well, this is a little bit crazy. It's a lot of money. $101,000. The moral of the story is try to start saving now. Hey, if you can learn one thing in this class, you guys, maybe start stopping that $5 Starbucks run every day and maybe start investing that money. It does grow and it will be worth more by the time you take it out. Okay? You'd be surprised how much money you can make if you start investing when you're younger. Look at the difference here. Just the length of investment. It's the same amount of money, just put into a bank for a lot longer. Okay, the question says, what will be the difference in their future values? Don't forget, we have to answer this. So 101 take away 5,557. 5,757. So the difference is $95,000, $704.65. Okay. Obviously, one person makes quite a bit more. Lena's older brother Cody, age 34, also plans to invest $1,500. Determine the future value of his investment at age 65. Okay, give that a try. Pause the video right now. So this is $24,168.61. Again, emphasizing that the longer you put something in, the more money it's going to grow. I mean, look at how crazy this is. This is only $24,000 compared to $101,000 just for a few more years. Okay, compound interest, the longer you leave something in, the more it's going to grow. Okay, I'm going to stop there. I'll give you a little bit of a homework assignment here. From the textbook, I'd like you to go to page 30. Okay, and I'd like you to do number 2, 4A, 6, and 7. Okay,